Okay, we're going to get started. Thank you everyone for coming. I'm Glenn McRae. I'm the Associate Director at the Transportation Research Center, and so we're really happy to be able to offer this and come over here to Rubenstein and have a look at a project which is a really interesting one for us, which will be a small part of what Jens is going to talk about, but we have a small coordinated project that we're hosting, which is between VTrans, DEC's Fish and Wildlife, and the Nature Conservancy, to do a piece of this monitoring, the monitoring that's going on that feeds into what Jens is going to talk to today. So this is kind of an exciting piece to bring on the campus. And the project's been going long enough in various editions. So there's some real substantive findings, and we've got a ways to go on the other end. So directionally, it's a really good time to kind of be presenting out and thinking with people about this. Jens is with the Community Wildlife Program at Vermont Fish and Wildlife. He's a conservation planning biologist, works a lot around the state, and with planning commissions, conservation commissions, but really was orchestrated bringing together the pieces of the project that we're involved in. We really appreciate his interest in kind of connecting back to UVM and the resources that we have here and thinking about these types of projects going forward. He's also a neighbor. It creates his own wildlife areas within our little corner. Burlington. So with that, I'm going to look nice. And just so people know, we are taping the presentation. Part of the service we try to do is create real-time interaction for folks, but also create a resource so that people can utilize it in addition to this. And there's a link on our website available to folks.
Great, thanks so much, Glenn. Hey, thanks for coming, everybody. I really appreciate your all coming today and being here. I did not do my thesis defense in this room, though I graduated from UVM's Field Naturalist program in 2003. But I do have a bit of that sort of thesis defense kind of feel today, so it's kind of fun. Even though we're taping, I'm not a particularly formal presenter, so feel free to interrupt me with clarifying questions. I really don't mind at all, and I'd much rather that you all can get something out of this than just listening to me talk. I wander a bit, so just so you three are put on notice, I'm wandering. Really what I want to do today is I want to talk about the connection between road ecology and climate change, and I want to make the case for why habitat connectivity in general is a climate change adaptation strategy. And I want to make the link between how individual road crossings are part of that larger piece of habitat connectivity. Perhaps more importantly, I want to make a pitch to UVM students, faculty, administration for a closer partnership, for more work together in the future. There's a lot of work to be done in this field, and I'm really excited. I mean, there's room for all of us, and we need academic research to be a part of this, as well as transportation and the Fish and Wildlife Department. All of us need to be together in this, and so I hope to make that case for the multi-pronged approach in looking at this work. All right, so I'm going to start. Feel free to grab a chair. I'm going to start by taking a look at just giving you a brief sense of the Vermont context within which all of this sits. We'll talk a little bit about some of the data sets that I use a lot for looking at habitat blocks and sort of looking at the pattern, the distribution of where there's forest and road across the state. Then I'll talk a little bit about climate change and how that's a piece of things. Get into road ecology as part of that, and then look at this sort of structural connectivity modeling. I'll explain what that means and how public-private partnerships such as this are ways at moving from structural to functional connectivity. You'll notice that my language is going to be distinctly unacademic. My bread and butter audience is explaining things to the public. So I really have made a career of not talking in jargon. So I'm really, you might notice a little difference, but that's very much an intention. So by way of context, Vermont is about 79% forested. We were about 20% forested in 1850. Some might call that the most successful ecological restoration of all time. Incredible changes on the Vermont landscape. So we're going to address that. But the other important piece of context is that we're 81 or about somewhere between 81 and 83% privately owned. So the roads and the private development that's associated with them is a huge part of the puzzle. And as you know, there's limited appetite for more state and federal acquisition. So the solution to maintaining Vermont's biological diversity rests very much in the hand of private landowners across the state, and our system for roads for where we allow that development to happen. So I just said 79% forest, tremendous ecological restoration, an amazing story. I want to parse this out. Forest or trees? You look at this photo, it sure is beautiful. There are a lot of trees in this photo, but forest? All right, well, look at this one. Sure, I can identify a couple large habitat blocks or forest blocks in this photo, and so I'm beginning to get a sense of larger groupings of trees. Perhaps we might call that a forest, but let's not be too quick in calling all of Vermont 79% forest. This is a picture of Stowe in 1962. I'm going to go through this series with you and just show you a little bit. So what I've done is I've digitized the forest cover, at least the tree cover, in this area of Stowe. And so I just want you to pay close attention to the pattern. 1962, 1974. First roads coming in, a little bit more development here. We also have a grading field, so a lot of the old fields are turning into forest. 1980, more road penetration, more grading fields coming in. 1996, we get some pretty big subdivisions. Notice that each one has its own pond. They're big on ponds. By 2007, we get a lot more of that subdivision. By 2011, according to the Vermont Fish and Wildlife Department's Habitat Blocks report, we no longer even consider that forest. It's less than a 20-acre parcel. So you see this shift. Now notice, between 1962 and 2011, there was no actual change in the tree cover. The old fields came up into forest, development took some of that forest away. So the only thing that shifted in that last 50 years is the pattern. But my contention is, from a wildlife habitat standpoint, that is not high-quality wildlife habitat. So that pattern matters a tremendous amount. Historic Preservation Trust has called Vermont one of America's most endangered places, a designation we've received twice now. Our rate of development is 2.5 times our rate of population growth. So people are taking more and more space for their development than ever before. And if you just look at the loss and not the agrarian fields, we're losing an estimated 11,000 acres per year to develop. So this pattern, the changes in pattern, from my perspective, matter a tremendous amount. So where is development happening in Vermont? It happens one house at a time. It's a slow pace of development. Many communities don't notice it at all. It's that one house at a time. But it's happening at low densities in rural areas. Development in Vermont is not happening in our village centers, nor in our growth centers. It's happening in our ag rural residential districts. We don't have suitable septic to grow our village centers the way the Vermont legislature says we're supposed to. we're growing is in our ag and rural residential districts. Estimated 2% of subdivision actually triggers Act 250. So we have this landmark in, environmental regulation, and it's pretty good for addressing concerns with commercial development. It fundamentally does not address the one house at a time type of development that we see in Vermont. So all this talk about permit reform and Act 250 reform is not actually getting at the problem of one house at a time type of development. Now, what you see here is a map of number of parcels. So that is not forest fragmentation. This is parcelization, but it gets at that issue by how many small parcels there are and how the number of small parcels is growing. So this gives us, this is one of the drivers of this forest fragmentation. Oh, sometimes this works and sometimes it doesn't. This is an animated GIF that shows that sequential development. And I tried it before and it worked, I promise you. This thing's fickle and I think I need to get rid of it. So what we see, the pattern of growth that we're seeing in Vermont is sprawl development. Auto-dependent strip development. Auto-dependent strip development. Now, this is Burlington to South Burlington and Shelburne. You might recognize that as sprawl, right? You recognize this as sprawl? This is ex-urban sprawl. This is the type of sprawl we see more of in Vermont than that Shelburne Road story. You recognize this as sprawl. That's that same development in Stowe that I pointed to earlier. So this is low quality wildlife habitat. And yes, the deer come up to these houses and they eat the hostas, and the landowners think they have a pretty low ecological footprint. But the overall effect of this clearing, these long driveways over a larger area, is forest fragmentation and reduced quality wildlife habitat. I'm going to check in. How are we doing? Any questions? All right. So let's take another case study from Venusburg. So look at these grayish dots. So those are all houses built up until 1999. And there are 998 houses here in Venusburg. And look at the pattern of those houses, mostly in the village and then on rural roads, somewhat clustered into little hamlets. Then look at these the houses built between 1999 and 2014. Look at the pattern of where those houses went in. That is ex-urban sprawl. The Vermont brand, the brand that we put up on all the New Jersey Transit railway stations. I'm not trying to offend. We do honestly advertise in every New Jersey Transit railway station. But the brand that we put up, come to Vermont, live, get your 40 acres and a mule, to quote a historical text. Be out in the woods. That Vermont brand creates this sort of sprawling pattern that is in fact reducing our wildlife quality habitat. So the Vermont brand has significant implications for our land use development pattern. So let's look at the flip side of this, that forest blocks data set, habitat blocks. These are areas of natural cover surrounded by farms, forests, surrounded by roads, development, and agriculture. What you see on screen, all the habitat blocks in Vermont between 20 acres and 150,000 acres are colored by size. So bigger blocks are darker, smaller blocks are lighter. The overall pattern, our biggest blocks are along the spine of the Greens and in the Northeast Kingdom. Where do we have the most biological diversity? In the Champlain Valley and along the Connecticut River Valley. We have exponentially more species in the valleys than we do on the icebergs. We have exponentially more conserved lands on the icebergs than we do in the valleys. So there's this interesting paradox in terms of the overall pattern of our forest cover across the state. Now, in my world, there are an estimated between 24 and 43,000 species in Vermont. We know something about a few thousand of those. The vast majority of the species in Vermont we don't know anything about. There's a lot of work to be done. But we use this coarse filter approach. We assume that bigger blocks of habitat have more biological diversity. This is research done in Maine And so this is a huge block of habitat that is a completely isolated 1 to 20 acre block of habitat. This is the list of species that block can sustain. Now, we could argue all day about having coyote drop out here or here or here, but the overall pattern is undeniable. If all things were created equal, larger blocks of habitat, more species diversity. If all things were created equal. But I already pointed out the pattern that our largest blocks of habitat are not where our species diversity is. So, but this is still something of a guiding principle because we've got so much that we don't know. So we cling to this as a first step in town planning. We cling to this that, well, all right, let's just look at the pattern of where there are big blocks of forest, look at the connections between them, and that's going to be our first step in figuring out what's most important in your town. Another sort of common filter that I use is looking at far-ranging mammal species. And with the hope that if you conserve enough land for some of these species with big home ranges, that some of those other ones that you don't know anything about come with you as part of the package. Well, average bobcat in the Champlain Valley, this is work done by Mark Freeman and sponsored by the Fish and Wildlife Department and done through the co-op unit. Average home range of bobcat in Champlain Valley, 27 square miles. They're moving, males are moving 19 miles per day, about 1 mile per hour. 27 square miles. There's no town in Vermont, by the way, that's 27 square miles. Average black bear between 10 and 20,000 acre home range. The river otter, 15 to 30 linear miles of stream. That SGCN that you've seen down here, that's a species of greatest conservation need. That's a designation that the Fish and Wildlife Department flags species, even common species, for saying we are concerned that there's a problem with habitat loss and those numbers may drop in the future. So these animals with with big home ranges are using multiple blocks to get what they need. So the basic concept is avoiding these isolated islands of habitat, these river systems that don't have riparian cover, where there are barriers to connections. The type of barriers I'm talking about, yes, roads. And I'm not just talking about the engineered surface of the road. That certainly can be a barrier for amphibians. Even a 6-foot curb can be a barrier to amphibians. But for other species, it might not even be the road itself. It might be the combination of traffic volume, traffic speed, and the time of day that traffic occurs. As rush hour traffic on 89, certain times of years, that more overlaps with crepuscular hours, dawn and dusk, where there's more wildlife movement, than at other times of years. So it's more tricky than we often acknowledge to figure out to what extent roads are barriers or not. Please don't just assume road equals barrier. There's a lot more nuance there. But certainly development and agriculture are other types of barriers we're talking about here. So the concept of what we're talking about is maintaining connections between these islands of habitat. And so I'm talking both about going along the river corridors, using that riparian network, and also connecting upland to lowland, upland to wetland. In that amphibian example I gave earlier, that upland to wetland connection probably is not associated with a stream, but that concept is always the same. So different animals, the scale of connectivity is very different. The amphibian movement we've seen this time of year, about 600 feet. Bears, we're talking about on a scale of many, many miles. So what connectivity means depends on the species you're talking about. But the concept is connect the blocks. So that's that same habitat blocks data set. And so here's Mansfield, Campbell's Hump, Worcester Range, Groton, West Mountain, Milton. In my work with local town planning commissions and conservation commissions, it's not rocket science to figure out where those blocks are closest together and where those likely connections are. We're in the enviable place in Vermont of still having a functioning network of connectivity. So I'm not talking about building a network of connectivity. I'm talking about maintaining what we already have. Don't screw it up anymore. We can also talk about habitat connectivity at a more regional scale. And here I'm really talking about genetic exchange. I'll talk more about this later, but looking at places like between the Tug Hill and the Adirondacks, between the North Greens and the Sutton Mountains. So allowing for exchange of genetics. A basic rule in conservation biology is if you get one individual to cross once a generation, that's enough for minimum genetic exchange. So what you see at left is what we consider the network within Vermont that participates in that regional exchange of genetic information. This is not to say that places in white and the connectivity there are not important. They are critically important for local connectivity, for maintaining those wildlife populations here, but they're not participating in this eco-regional genetic exchange. They're not of as much importance. And a lot of this white is because of the lake, and in our modeling, we're still trying to suss out to what extent the lake is a barrier. I don't consider the Connecticut a barrier at all. I have anecdotal reports of bear and moose swimming across the wide part of Lake Champlain. It doesn't happen very often, but when it does happen, it's an incredibly important deal for genetic exchange. Mostly we acknowledge the connection between the Greens and the Adirondacks down here, and I'll pick up on that in a little bit. So there's this regional picture of genetic exchange, but do you know what it all boils down to? Lots of local road crossings. And so I don't know if that moose that's going across Route 12 outside of Montpelier is an Adirondack moose or a Green Mountain moose, but I know that we need to get that moose across Route 12. So these individual wildlife crossings, when you sum them up, allow for this regional network of habitat connectivity. It ain't rocket science. Look at this picture. They're not hard to spot. This one I'm not even convinced about. It's sort of stepping stones. This is in that Greens to Adirondacks linkage. They are, you can see them, you can experience them on the landscape. The good thing, from my perspective, about a more fragmented landscape is our modeling works better because there are not that many options. So this place sings in structural connectivity modeling because there's a whole lot of open land here. So it's fairly easy to predict where we'll get the crossing. So there's, you can experience these crossings. Let's just take, back to Mark Freeman's work, let's just take a look at what connectivity looks like for one particular species. These are Bobcat points. This is the north part of Shelburne Pond. This is Route 116, almost up to St. George. This is where it does that big turn. So this is the second part of 116 where people drive way too fast and then realize they need to slow down right about here. So what does this landscape look like from a bobcat's perspective? Well, they're spending a lot of time in the mixed softwoods. They're spending a lot of time in the wetland itself. There's still enough cover for a bobcat, but it's great hunting. But look at this. A hedgerow and a row of trees. That was sufficient to allow that bobcat to feel comfortable enough to cross this ag field. I guarantee you that homeowner has no idea of how important that tree line is for bobcat movement across Route 116. Let me give you a couple more examples. Different cat, we're in Shelburne, right on Route 7. Again, that riparian forest is pretty important, spending a lot of time there, right at the edges of the wetlands. Look at that spot. I know there's movement across Route 7. I know it's happening. Where? Well, there's a long bridge structure right here. It's actually oversized. The abutments are pretty far back away from the edge of the stream. there must be about 20 or 30 feet of dry land under normal flow conditions. That's the spot, even in Shelburne. So the design of particular structures is critically important in this addressing the wildlife crossings. This is a picture that James Brady from VTrans, Agency of Transportation, helped engineer or set up the camera for. It's a 250-foot dry culvert under both barrels of I-89 and Route 2. It's what, 4 or 5 feet wide? 250 feet long. We had no idea that fox would tolerate that. Maybe it's a particularly gregarious fox, I don't know, but he did it. So the specifics of how these structures are set up and the landscape context within which they sit matters a great deal for this overall network of connectivity. I'm not just talking about big fuzzies. Aquatic connectivity, similar concept, connect the blocks. That's a hanging culvert. For fish species that spawn upstream, that is a copy access. This, from an aquatic organism perspective, natural bottom helps with flood resiliency and allows for aquatic organism passage. With the help of the Army Corps of Engineers, aquatic organism passage is the default setting for all new bridges and culverts put in Vermont. So there's a regulatory hook on the aquatic organism passage front that's enabled a great new design, a suite of designs in culvert engineering. From my perspective, just to quibble a little bit, I want to see that even bigger. I want to allow for some dry land on both sides of that stream to allow for terrestrial animal movement as well. So some people say oversized. I'm going to say appropriately sized. Appropriately sized culverts are critically important to this overall network of habitat. And these riparian habitats, these riparian corridors that the culverts connect are fundamentally important passages for up and downstream movement as well as upland to lowland movement. So, climate change. It's, some people might call it a problem in and of itself. I think of it more as exacerbating problems we already have. The forecasts are pretty grim. What you see on screen are a low emission scenario and a high emission scenario. Perhaps you've seen this before from the IUCN. Under the high emission scenario, by 2070, Vermont's climate more closely resembles Georgia than what it is today. And just a footnote, our current emissions are exponentially higher than the high emission scenario. So this is a dramatic change that's headed our way. What the forecasts hold: more precipitation, more of it in the form of extreme weather events, more of it as rain and not snow. So already we've seen changes in the number of frost-free days. Great for getting your vegetables started a little earlier, but perhaps problematic for the natural communities of Vermont. We've already seen from 1958 to 2011, 74% increase in very heavy precipitation events in the Northeast. So we're getting more extreme events. We're expected to see more summer drought and more extreme rain events. Interestingly, from a transportation perspective, in Burlington last year, they used more salt in the first month of the winter because of all that ice than they had the entire winter the year before. So perhaps climate change looks like an awful lot of ice for us here in Burlington. And just to take that one step farther, because my wife is a health professional, the number of falls due to ice increased dramatically as well. So she's seeing all sorts of broken bones. A kid, as she works at Champlain College, a kid this winter fell on the ice and landed on his nose. No arms, no nothing, just right on his nose. forgive me, I shouldn't laugh. But there's there are interesting ramifications for climate change that are perhaps more sophisticated or more complex than we thought. Nose wounds. So really what we're talking about are increase in severe and erratic weather events. The trends in flood magnitude, we certainly see that here in the Northeast. There's an increase in flooding magnitude. The trends in hurricane intensity in the North Atlantic Ocean, a dramatic increase in the number of Category 4 and 5 hurricanes. So we're seeing a lot of changes with climate change. We're seeing changes in climate conditions for different forest types. Some really dramatic shifts in forest composition. I usually take these sorts of models with a grain of salt. Bill, I'm sure you'd have a lot to say about things like this as well. But what's interesting to me, we name our natural communities based on the current species composition, silver-nape ostrich fern floodplain forest. As the actors move around on this stage, I think we're going to have to rename some of our natural communities to speak more toward their function than their current species composition, the actor that's currently on this stage. So we're already seeing range shifts. I believe it was the 2012 Journal of Nature cited entire populations moving away from the equator on average 1 mile per year, already documented, north and south away from the equator. 1 mile per year, already documented. So these actors are already moving around on this stage. So climate change is accelerating. What do we do about it? There's an awful lot of focus on the mitigation side of things, reducing our carbon. Great, I approve, yes, we need to do that. But even if we stopped our carbon output today, we're still dealing with the effects of climate change. So this adaptation side of things hasn't gotten as much attention as it needs. Well, I want to make the case that habitat connectivity is critically important adaptation strategy. That's how we allow for these actors to move around on this stage. We maintain our network of connectivity. Furthermore, addressing the barriers, roads, within this network is fundamental to ensuring connectivity. So, what are we doing? Vermont Fish and Wildlife Department and the Agency of Transportation enjoy a wonderfully positive relationship. We've been working together for decades, and now it's really incredibly positive. Some of my colleagues from VTrans are in the room, and it's really been amazing to see what we've done together. We're engaged in highways and habitats training for VTrans staff that Chris Lazar began, for really helping to change the culture of VTrans, to help getting their staff familiar with the wildlife and the habitats that they're working in. That training is in the field, and it's an exchange in both directions. VTrans staff are learning a lot about some of these habitats and natural features. Folks like me are learning a lot about engineering and words like abutments and piers that I really didn't know about before, and then I make up my own, like super elevation, that aren't exactly an engineering term. We've had some success with some structures specific to wildlife. This is the Bennington bypass, and one of the underpasses that allows for deer movement between a winter range and summer feeding. But these are incredibly expensive. This is the Cadillac. We don't get these very often. A lot of what we've done together so far has been focused on structural connectivity modeling. The structural piece is where the structure of the habitats, where are there trees, deciduous and evergreen trees close to both sides of the road? What's the structure of the habitat look like? So we developed a seamless cost surface, and I say cost in the sense of cost to animal movement. For all of Vermont, with lower cost for movement within the blocks and higher cost for movement across the roads. From that cost surface, we've developed a variety of models. establish an anchor. This is the Worcester Range, and an anchor here in the kingdom, and do several runs between where's the least cost path between these big anchors. And then we'll do a run for the Lowells and a run for Groton and a run for Stannard, and put all those different runs together and create networks. So we have a sense of what the network of wildlife habitat connectivity looks like in the area. Please notice that I'm avoiding the use of the word corridor. Part of that is because of it suggests something of a linear feature. And that's appropriate out west, where they have, the path of the pronghorn and this several mile linear feature between two huge blocks of federally owned land. So that corridor language makes sense in a linear western sense. It doesn't work in the Northeast. What we're experiencing, what we need, is more of a network. Wildlife movement, even in response to climate change, is not a linear north-south feature. Particularly given that highway for north-south, that wildlife highway for north-south, is along the spine of the Greens at our highest elevations. So the network of connectivity is the kind of language that I'm using here in Vermont. So this is a lot of the work that we've done together over the past few years, and I've been peddling models to VTrans for quite a while now, and it's I don't know how many of you have tried explaining GIS models to a group that has limited investment in GIS. It's a difficult task. And so we've certainly made some headway. I'd say we've made much more headway with the Highways and Habitats program than through the use of these sorts of models. So what we're doing is oh, forgive me, I missed one model, is this linkage ratings model. For using that cost surface to figure out what road sections are the most important. This, by the way, we call Moose Alley on Route 12. Peddling models is a tough business, and we need to move beyond that. We need more data, we need better quality data, we need more convincing data to move beyond structural connectivity models to have proof, dare I say, of animal movement, of actual data that backs up where wildlife are moving. So some of the work, some of the success we've had in moving to that functional connectivity is here. This is a Little River in Waterbury. That's I-89, let's see, northbound, southbound, and Route 2. And notice that the procedure had been to install 3-foot boulders underneath to protect the abutment. And so there's a boulder field right under bridges in Vermont, older bridges in Vermont. This was our first effort at it. So this side of the river is the same as that side of the river. The images are flipped. So in the fall of 2013, VTrans, with help from VTrans Environmental and Fish and Wildlife, installed a wildlife shelf. We put dirt, rubbing, from the construction project on top of those Type 3 boulders and made a continuous path. Yeah. May the following year. Average from data from out west suggests 5 to 6 years for wildlife to adopt an engineered solution like this. Our deer are smarter. So already we're getting our first deer movement. Our cameras just upstream, and I'll explain the camera project in a second. Our cameras upstream have picked up black bear within 100 yards of its crossing. So this is a place where we've got a 74,000 acre block directly north of it, a 54,000 acre block directly south of it. This is the barrier, and suddenly we've got a nice dirt path in between. So tremendous success. Buoyed by this success, VTrans has changed its grubbing spec. So now we cover all of those boulders under bridges as a standard practice. The cost difference is minimal when you're actually installing a new structure. So incredible things are already happening. Another success has been figuring out how to pull in the NGO and the academic community. The time scale that VTrans and Fish and Wildlife operates, I mean, VTrans is planning many decades out in some cases. And so the citizen activist that says, wait, not Route 7, well, chances are that person's 5-10 years too late in their complaints. And it really annoys VTrans when they come into the permit process after something has already been permitted. So figuring out the appropriate place to involve citizens, to involve the NGOs, and to involve the academic community has been really important, getting that temporal connection. So Staying Connected initiative is a partnership spread out across the provinces, Canadian provinces, Nova Scotia, New Brunswick, Quebec, including 5 US states, Massachusetts, New York, Vermont, New Hampshire, Maine, focused on sustaining critical landscape connections across the region for the benefit of nature and people. So Staying Connected has been a really effective umbrella for bringing in other partners. So I showed you this a little bit earlier, but these are the landscape, the linkage areas that Staying Connected is focused on across the Northern Appalachians. James and I were right here 2 days ago talking to an awesome group of New Brunswick and Nova Scotian Department of Transport and Department of Environment and NGOs for looking at road crossings in that area. Very different context. Very fun. So this Staying Connected partnership has been able to plug in the NGO and the academic community in inspiring ways. A lot of the work we've done together, this transportation connectivity guidance document is really getting best management practices for connectivity institutionalized in VTrans. We together have pulled off hosting the 2014 Northeast Transportation and Wildlife Conference. We're engaged in tracking and camera monitoring, which I'm going to pick up on next. So as sort of a sign of this success, the Federal Highway Administration has asked us to do a national webinar to talk about this Vermont model and how applicable it is to other institutions across the country. How the Fish and Wildlife agencies and agencies of transportation can work better together, and how we can plug in those NGOs and academic institutions at the right time. So the multifaceted approach of Staying Connected is really important, because the conservation science fuels it, but then there are all these different options, different tools, different directions that science can flow into. This is how you bring science to action. You don't have just one tool. You have multiple tools, and you have different groups of partners around each of these tools that can make it happen. And so the key becomes the handoff from the science organizations to the transportation officials to the land protection. And some places, one tool is going to work better than another. And we're going to talk about that in a second. So these are the Staying Connected linkage areas in Vermont. I'm just zooming in. Greens to Adirondacks, Greens to Conics, North Greens to Suttons, which are up here. We call this one Worcester's to Kingdom, but it's actually part of the Greens to Whites to Blue Mountains of Maine, uber linkage across all of New England and then into southern Quebec and Nova Scotia. So Staying Connected has helped us move from the structural connectivity modeling to functional monitoring. Our first effort at this was the Critical Paths Project, and we looked at a few road crossings, east-west roads, that bisect north-south movement. And so we hired professional trackers, did a GIS pre-filter to figure out where there was structural connectivity, then hired professional trackers to walk those road sections and figure out where there was the most species diversity of road crossings. So Critical Paths was our first effort in that direction. This is the Greens to Adirondacks linkage, Lake George, southern Lake Champlain. And so we hired other professional trackers and got, this is just Bobcat and Fisher, but got a sense of the hot spots for those species. So this road tracking work has been a tremendously important for getting us closer to this sense of functional connectivity. We also, Staying Connected has also been engaged in a variety of volunteer tracking programs, while citizen science data, you need a few years to believe it. But maybe more importantly than the data is the awareness that this brings. The program up in the North Greens, the Wild Paths that did this work, was really instrumental in changing the awareness of people. The participants would say, wow, we had no idea there were so many different species here, and that so many of them were crossing the road. We just didn't know. So that community awareness piece that the wildlife road tracking brings can be pretty awesome. Also scares the heck out of me to have citizens on the road who aren't careful enough. So there's definitely a balancing act there. We do a road tracking, our professional tracker does a transect along I-89 in the median, and James tags and follows him with a V-Trans vehicle, with massive flashing lights, because all we need is one do-gooder citizen to pull over to help Alan out, and we get a massive accident. So the safety concerns here are important to note. The project that Glenn was talking about earlier is a structures comparison, and looking at different class sizes of structures, transportation structures, to assess the diversity of species that they're moving. Also looking at the landscape context within which those structures occur. So it's a partnership under the umbrella of Staying Connected through UVM's Transportation Research Center. Nature Conservancy is coordinating the effort. V-Trans and the department are partners. So this was last Friday, and here we are. This is why Staying Connected has been so successful. James Brady from V-Trans, Paul Marangelo from the Nature Conservancy, and I'm taking the photo. Glenn, we need you in that photo. In fact, what we need in this photo is UVM students and faculty. So the next time I take a photo like this, I want to see more of you in that photo. There's tremendous work to be done here. There's a great opportunity to involve students and faculty, to have that academic research component. We have a lot of labor needs. I really encourage you to get more involved in this kind of work. There is an umbrella under which we can do this together. So what we're using, Connex PC900, that's a top-of-the-line game camera. They don't get any better than that. It's an infrared trigger. We're taking 3 pictures. So there's a trigger and then boom, boom, boom. So it feels like video. During the day, it's got about a 60-foot cone of detection. At night, that's about 45 feet. I always say this because when I show this to hunters, they're like, hey, where was that camera again? So yes, there are security codes that make it unusable if it's tampered with, and we lock them, have double locks on them. But anyway, the camera placement is critically important, especially in our more remote campus. Where we put the camera, which direction we point it in, matters a lot. So we need to take camera data. We need to approach it carefully. It's not gospel. Where we pointed the camera could be missing everything that's moving right beside it. So let's be careful here, but it is amazing. So here's that I-89 study from Bolton and Waterbury. I've got 40 cameras deployed. We've got transects here. So we have professional trackers hiking those transects and recording all the species diversity. Then we do a transect this way that I just spoke about with James and Alan. And we have cameras at transportation infrastructure, the bridges. Little river is right here. We're beginning to get a handle on movement across I-89 in this most important part of Vermont for connection between the North Greens and the Central Greens. We have another ongoing camera project. This is the one that the university is involved in between, this is the Worcester Range, these are the Greens, and this is up towards the Northeast Kingdom. And so this is that Worcesters to Kingdom linkage. And so we're comparing different class sizes of culverts across that area, seeing, well, what size or what type of culvert moves the most species of wildlife. So just some fun photos. We have tremendous numbers of deer in the thousands. and moose and bear. The preponderance of big animals in that Bolton Waterbury study has got us wondering about camera placement and height. And so the subsequent work, we brought down the height of our cameras. Initially, we were really worried about vandalism. It's a $600 camera. But we weren't picking up as many fur bearers, small animals, as we thought we should. So we brought the height down to change the trigger zone of the camera so that we get a more land area within the trigger zone. One of the important ways we're getting at this is through field checks. This is Alan and myself. We're actually tracking a fox, and it didn't get picked up on our camera. And this camera is 10 feet up in the air. And so it's anecdotal evidence like this that made us think we need to bring our cameras down a little bit. So, last point. We're moving from science to action. But what that action looked like is going to be different in different places. This is a 3.3 mile long section of 242 coming off J. The on the ground road tracking found that whole section is important. It's just after you leave the guardrail coming down and just before you hit the development in the valley. So the implications for how you manage 3.5 miles of low but even density wildlife crossing is very different than it is here. This is Route 4, right in Mendon. That's right, the Inn Long Trail. It's right past there. That's 0.2 miles long. So maybe the tool that's most appropriate in a place like this is land use planning and looking at overlay districts or zoning to say, hey, we need to limit development in this area. Incidentally, there's no power. So for the moment, that makes things a lot easier for reducing development along this section. But you know, there are all manner of off-grid homes going in Westfield and Jay. So I'm not sure this section is safe. But you know, the implications, my point here is the implications for what tool you use is different. We did work with the Mendon Planning Commission, and they said, you know, this thing is 0.2 miles long. We really don't want to zone for it. Can't you just buy it? Go talk to the landowners. And so we began engaging our land trust partners have begun engaging those landowners to say, gosh, that's a really important section. Your place is maybe more significant than you thought. So there's a lot to say on this movement from science to action and the appropriate tool. But it's critically important that we understand that that multi-pronged approach is how you get to different kinds of action. All right, with that, thank you all very much. I appreciate your time and attention today.